One of these topics is derivatives of inverse functions. And you'll probably hate it. It's not that it's crazy difficult. You're going to hate it because you have to slow down your thinking to do it. So you guys are very used to doing something enough that you get very quick at it. Like power rule. When we first learned power rule, you had to stop and think about how to do it. But now you can probably just find the answer without really slowing down much at all. Like you can probably just write the answer as you see it. Derivatives of inverse, no matter how much you do of it, you most likely won't get to the point where you're going to just be able to write the answer. In my opinion, worse, is that this is really this section and the next section, the only time we deal with inverse. And then you're not going to have it again until the AP test, which means you are almost guaranteed to forget all of this after we're done with the chapter. So before the AP test, we'll probably review this topic because you're just going to forget the parts of it because we don't really use it frequently. And as you'll see, it's just kind of... Sebastian, I think you volunteered yesterday, didn't you? Okay. Do you remember what an inverse is? Oh, well, that was a very quick answer. I mean, it's good. At least you didn't pretend. Okay, I thought it might help if I just talk about inverse before we go through the notes and kind of what we're going to do with it. Because there's going to be two methods to doing these problems. One method is following a formula. One method is just figuring it out. Also, I've been kind of wait. I have graph paper, don't I? Oh, there's background probably. Oh, I was kind of hoping the keyboard would pop up. What happened to my blank? Logarithmic? I do not want logarithmic graph paper. Okay, that was a lot of work for nothing. Why am I forgetting how to put a background of... Suppose you guys don't remember, do you? Hi.
Hi.
Thanks. Where's Bianca? Wait, she's not in this hour, is she? She's in the other class. This is from last trimester. Oh well. Okay, we'll just... let's say I have that point, what would be its inverse? Would that be easier to ask that?
-1.
Yeah, perfect. The inverse is with the x's and y's reversed, inverted. So -1, 3 would be the inverse. You probably learned inverse the first time because your teacher had you switch the x and y in the equation and then resolve for y. That's probably how you first did it. We're mainly focused on the slope. Wait. I didn't put you on the seating chart, did I? Did you just come in? I probably put you on the seating chart then. I think I had it up on the board. Okay, remind me to check after I stop I'm pretty sure I put you on it. We're focused on the slope, because that's mostly what calc is. Let's just guess the slope for this line. Let's call it 1/10. We'll just try to make a number that'll be easy to work with. Do you guys remember how to draw an inverse? Does anybody remember that? Rather than calling on a specific table? Do you remember doing f of g of x in pre-calc? Like how to check if something's inverse? If you take two inverse equations and do them as a composite, so f of g of x, if they're inverse, the final answer should just be x. Did you guys not do that? Does not ring a bell. Okay, I'm guessing not if nobody's really remembering this. That's usually what was taught in pre-calc, but I know you guys have a different book, so that's how you check if something is inverse, is you combine the two equations together, and if combined, they leave just x, then it's inverse. And so the reason for that is because y equals x. Every inverse is going to be a mirror image around y equals x. Did you guys not ever do any of this? Even in Algebra 2?
I did.
He was in a different state though. It's looking good for Colorado right now. Not for us.
Did you teach me this in algebra too?
Yeah.
I don't remember.
I did. Well, yeah, I did in Algebra 2.
I don't remember.
Okay. Well, I was going to ask you what would be the slope at that spot, but I'm just going to take it from this that you guys are going to have no idea because you've never drawn inverse. It'd be 10. Yeah, it would be 10.
Not negative?
Okay, let me restart. You guys remember a lot less than I was expecting, so let me restart. I'm really glad I'm doing this then because I'm pretty sure that the packet would go horribly if you don't remember the basics. Okay, so let me draw y equals x again. And if we have, I'll draw like a natural log function. So like ln of x. So if I draw ln of x, we know one of the points would be 1, 0. Now, if I do a mirror image around this dotted line, it's much easier if you do it on paper because you can rotate your paper so that the dotted line is straight up and down, and then it's very easy to draw mirror images that way. On here, not as much, but it's not terrible. If I know I have 1, 0, then I also know that 0, 1 is its inverse. And when I draw the inverse, it should make a mirror image around y equals x. Wonder if I should do regular log. Nah, we use natural log more. Do you guys happen to remember what the inverse of ln is? E to the x. So this is an exponential graph. So they're inverse to each other. And if I would plug each one of these equations into each other, so like if I did e to the ln of x, do you kind of remember that the power, or the base and the power cancel each other out sort of? So that would leave x. And then if I did ln of e to the x power could come up front as a multiplier, ln of e is 1, so it just leaves x. So they're inverse. And we do know slopes. What color have we used? Sure, purple. So only because we know derivatives do we know the slope. So the derivative of ln of x is 1 over x. So at x equals 1, the slope, that's a terrible example. That is actually the worst example I could give. It would be 1. That's why I didn't want that example, because the inverse of 1 is 1. So I didn't want that example. Let's pick a worse spot, like 2. So ln of 2 is, I don't know, something. Oh, I suppose I have to actually, somebody have to calculate a rate out.
Could we just take E because E is just like a little bit
Sure.
more than 2?
It's a good idea. Good idea. The inverse of that would be 1e. And if I do the slope at e1, it would be 1 over e. Which is,
Approximately
Point.
5.
what is it, 0.35?
Yeah, approximately.
Did you do that off the top of your head?
I didn't memorize it. It's like 2.36 something.
That is impressive. Okay, now, if I draw the slope at the inverted spot, it is also positive. So my first picture wasn't that great. I was just trying to draw it really fast. And that's why as soon as somebody said, shouldn't it be negative, I wanted to redraw it. Because well, yeah, but it did look negative, that was the problem. That's why I wanted to redraw it. What should be the slope at the inverted spot is your estimate. Correct. So the slopes at inverted spots, you're just going to flip it upside down. Now, at first, it feels like it should be the opposite sign, basically because you're so used to doing perpendicular. But that's just for perpendicular. These don't have to be perpendicular and frequently aren't. It actually does make a lot of sense if you think about it though. When you guys first learned slope, the formula was y2 minus y1 over x2 minus x1. And the whole point of inverse is that you switch the x's and y's. So you're literally just flipping the x's and y's. And so the slope should just be upside down. From this example, let's say you were given f of x. Do you guys remember how they notate the inverse? -1, yep. So this would be f inverse of x. If we are asked to find f inverse of 1 prime, this is asking you to find the slope of the inverse at x equals 1. So one way we can do that is to figure out the slope of the normal function at the inverted spot and flip it upside down. So, like this one, I would figure out what is the slope at x equals e, not x equals 1. I'd figure out the slope at x equals e, which is 1 over e. And then the slope of the inverse would be upside down. That's this section. It's not horrible, but it's not something you're gonna just like instantly go through fast in your brain.
Is that because you wouldn't know like the actual inverse function?
Correct.
Okay.
You're gonna be told information about the original function, and you are gonna be asked to find the slope of the inverse. This is the method, FYI, this is obviously not the formula. And I know some of you are gonna find the formula just easy for you because you're good at just filling out stuff. That's great. Some of you are not good at formulas, and so this is kind of what you do. Not great as well. This one doesn't have a good method, and it's not gonna be hard once we start doing it, but it's also just like something you can't fly through. So, that's our topic, before we do anything in the pack. We kind of okay with that? Okay. Well, I only took 3 examples just to try to draw one that was okay. Okay, on page 1, sure, it gives you a definition of an inverse. I didn't think that would help to give you that definition, even though it's correct. Then it gives you, I believe, a table and kind of asks you to figure out inverse information from the table. So we have this table we're starting with 3 different x values and an f and a g. Finally, you guys get to call in another table. Way to go out of, safety zone here, okay? So your table, I was hoping you could help me fill out that box. What would I put under the x column? This is for the inverse information.
I think you do like the f of x.
Perfect. The x column is going to be coming from the y values or the function values. That was pretty good. I didn't know if anybody would get that before we even talked about it. I mean, I could tell you didn't sound very confident, but that was very good.
It's y, right?
Correct. Yep, and they're not going to be labeled as y because we're using functions. So the inverse is going to be the original x values. Okay, can I immediately fill out the other one too, probably then? Okay, x values, and then these were the original g values. Because all you're doing is swapping them. That's inverse. I mean, we don't really use inverse much at all yet. Inverse is very helpful, common, once you go to specific areas that you want to study in college. Like, there is specific uses for inverse, and so you will use it a lot more. When we try to teach you generic things, it's kind of difficult because there's not really specific purposes for it. Okay, this is what I wanted us to do, because if you use the formula, you have to be good at filling out info like that. Are we okay with that? Table.
Yeah.
Pick one, or go. 1 through 11, or no, 1 through 10, because 11 and 12 have gone.
6.
6, 6. Okay, do you guys want to come up here, or do you want to just tell me what to do? All of the answers from this are coming from the 3 sets of information above.
So we're just conferring.
Oh, okay.
That's fine, that's fine.
Yeah. So
What's the first thing we fill out in that box here? What's the first thing we
the
figure out?
inverse of g.
Perfect, so we need to figure out g inverse of 0.
Yep.
switch you go over to it, you get 1.
Okay, good. And if you think about it too hard, this x value is not, oh, this x value is not the x value from that original table. So this was what, 1?
Yes.
Okay, so now we are going to do f of 1.
Which gets you -1 based on the original.
Yeah, I can't see it, so yeah, okay, perfect. I'll take your word for it. Excellent. So the variable, I shouldn't say the variable, the function that you are focused on is going to be the information that you use to figure it out. Because the x's and y's are not the same depending on which set of information you're trying to pick. And that's what's going to happen in our formula for derivative of an inverse. You have to focus on the x and y values of what you're focused on. Okay, good. I don't know, should we fill out the rest of these? Do you guys feel like you can do them on your own? Okay, try that. And if one of them feels difficult, then we can just do it together.
How do you do E?
Because you get 3, and then there's no 3 on the other graph.
Oh, that's not good. G inverse of
No, I
-1.
mean here.
Okay.
Right, this is your X.
Oh, would you have the inverse there? You have to go the opposite way? Yeah, that's why we're seeing.
Nope. Correct. Can't do it.
Yeah.
My guess is this was supposed to be regular f. No, because that's the first. Oh, yeah, it's similar. My guess is that was probably supposed to be regular. Because there is a 3 in the other column, so that's probably where a typo is. If nothing, it's just helpful to know that you can't find that answer.
And then
So is everybody else running into issues on E probably then?
Yeah.
Okay, my guess is this is a typo and it's supposed to be just regular F. Because there's a 3 in the other column, which means the original set of tables would work. Okay, but this is a good one for us to focus on quickly too. If we had equations, if you had an equation for F and for G, how would we find F inverse of 3? You're saying it right, but if we actually know the equation,
after you found the inverse function, like at the inverse equation,
you're not going to be able to find the inverse function.
oh, so you can't find that, okay.
No, because you're generally going to get functions that switching the x and y don't help.
Oh, okay.
Like they'll be complicated enough that you can't figure it out.
Can you guess by finding the inverse slope and then estimating with that?
I think you're answering a different question, is my guess. Only because this one has no prime notation anywhere. Oh, you're saying by looking at a picture almost?
Yeah.
Oh,
Like finding the slope and then it's a guess.
gotcha. No, we don't want to do that. That's not a bad thought. Well, you said it originally, but you didn't sure what to do with it. I think you said find when f
Oh,
is
yeah.
3.
When f of x is.
Yes,
Because it'd be like the y value.
correct.
Yeah, can you set f of x equal to 3?
Perfect. So if you actually know the equation, you can make whatever f is equal to 3 and solve that. I think that was the track you were on, but you were going slow. If not, we'll make it sound good. Okay. So these are the questions we're going to get because you're going to have a function. You're not going to have a table, you're going to have an actual function, and so you would set that function equal to 3 and then solve it. And then that would tell you what f inverse of 3 is. So when you're doing that, basically the question mark swaps. That's what we're gonna try to do. I believe this page is just the one about composites being X. I think the bottom was the same, correct? No, here we go, we'll try this. I always thought that was on the next page. It says, given f of x equals 4x minus 3, sounds good. And you're told that f prime of 2 equals 4. Oh, normally we don't know that info, okay? But I guess we could figure that out easy enough because finding f prime is easy. Find the value of f inverse 5 prime. So first, I'll kind of try to show you the method that I usually do for these to figure it out. I don't know why, but for me the formula for this one feels more complicated, and it just screws up my brain. So I have to try to think about these problems to do it. So this is what we're given. We're asked to find f inverse 5 prime. That's what we're trying to find. Well, if we're trying to find the slope at 5 on the inverse, then that means we want to figure out what is the point on the inverse. Like, we want to know where it's at to be able to figure out the slope. Okay? And we need to fill that in. If that's what we need to figure out, then that means I want to figure out when the original function is equal to 5. Because that's how inverse works. These two numbers swap. Okay? Well, this I can figure out. This I can figure out because I know that equation. So 4x minus 3,
Yep, that'll get you.
4x minus 3 is equal to 5. FYI, I have found out throughout this year so far, like, my smartboard is one of the best ones apparently. I will take it shutting off occasionally. Because like, Sardini's smartboard, he's on his 3rd smartboard. His would show up random, like the code that they use to make the smartboard would show up on the screen. His second one, which is currently on the wall, flashes constantly. And the third one they dropped. So, and I've had apparently a ton of other people, theirs just freeze up all the time and they have to reset it a million times. So I'm totally good with mine shutting off occasionally. Okay, 4x minus 3 equals 5. Add 3, get 8. X is 2. Okay, the only reason this 2 is actually important that's important is because we can figure out the slope at 2 very easy. Now, normally you will not be told that. This one I told it to you. You will normally not be told that. So the slope at 2, if you do the derivative, you would get 4, and or we're told it. So I know that answer should automatically be 1/4. If I know the slope at the inverse point, the slope is inverted.
Couldn't you just completely skip the second step for this equation?
Just because the slope was already known?
No, because the slope is like constant, like it's
Yeah,
Or-
that's what I mean, you knew the slope.
yeah.
Yes, this problem you could.
Okay.
The other ones, no.
Yeah.
That's why I wanted to go through and show you the full method, but 100% you're correct.
So, but just the inverse function of that, yes, that.
What is that?
Yeah.
That would be 2. but we actually don't need it, so that's why I didn't fill it in. But it would be 2 because we found out over here, 2. Yeah.
I was confused with how you went from 4 to 1 4.
Um,
That was 1. Yeah, where the 1. Yeah, I saw that. I was wondering where the 1 came from.
It's just.
Well, that's what I was trying to show you.
Yeah.
Because
Oh, so these slopes, you flip them upside down. So if this is, oh, it's at the bottom. If this has a slope of 4, come on,
Yeah, it-
that has a slope of 4, 4 being flipped upside down is 1/4. Yeah, it's not always going to be a 1/4. Okay? This is the method, but for better or for worse.
Wait, it won't always be this number?
No, but if the slope is like 2/3, that's 3/2.
Oh, I see, but if it's a whole number.
Yeah.
Okay.
Yep. So the method is that you write down what you're trying to find and you work your way backwards to get the information. If that makes sense to you, I would just use it and I would completely ignore the formula. So this is the formula. It's not terrible looking, like, the formula is not horrible. The horrible part is just trying to find the information for it. I mean, that's all. Not that it's terrible. Except for having to memorize it. That part's horrible. Trying to remember the primes. Okay, so the formula is actually essentially the same thing. The first thing you find is inside the parentheses. You have to find the inverse original function information. So that was the 2 that we found first. Then you have to find the slope of the original function. That was the 4 that we found. So the final answer is 1/4. So the formula works the same. It's the same everything. It's just for me, it doesn't click. Like, for whatever reason, my brain has a hard time working with that. Okay, so now we have a table. Actually, no, wait, do we have time? Yeah, we'll do this problem and then we'll cut it off. Okay, because the more we get done today, the less we have to rush and we can take time to work on problems that'll confuse you tomorrow. So it says find G prime of -1. This I really dislike, but they also do it on the AP test. Sometimes they refer to G as the inverse of F. So they don't always call it F inverse. Sometimes G is the inverse. But they have to tell you that if they do it. So it's not like it's going to be just guessing it. So this is saying find the inverse derivative at -1. Okay, should we try to use the formula method probably, right? So using the formula, I'm going to write a G because that's what F inverse is. G prime of -1 is going to be 1/F prime of G of -1. Okay. Now we are told the original function information and the original function slopes. If you would like to fill in G and G prime, you can. I'm not too worried about you filling in the table. We can figure it out on the way. G of -1 is going to be where F is equal to -1. Wouldn't be a terrible idea to write that little note to yourself, because this is super easy to forget. So F is equal to -1 at x equals 3. So G of -1 would be 3. Finding F prime of 3 is super easy on the table because it just directly tells you. But, so F prime of 3 would be -4. So 1/-4 which you'd probably just write as negative 1/4, but whatever. So this one went very fast, mainly because you had a table of answers. It becomes more difficult when you have an equation and you have to find the answer. But that's how you use the formula. Decide which works best for you. I can always do both. Okay, I'll stop there. Like I said at the beginning of the hour, you're not gonna be able to fly through this. No matter if you want to or not.
Harvard is not.